Now another effect of Doppler's effect sound is when the source at rest and our observer is moving away. Whenever the distance between source and observer is increasing, the apparent frequency will also decrease. So let us suppose at the beginning the source is that this is the source which is producing the sound and sound moving toward the observers. Now these are the wave. Suppose we can say that this is one wave. One wave means the length of, if the length of the wavelength is lambda, then it is called one wave. Now in 1 second, suppose in 1 second, the number of waves received by the observer is at rest and your source is also at rest, when both are at rest. In 1 second, the number of waves received by the observer is suppose f naught. F naught, number of, this is the original frequency, number of waves received by the observer in 1 second. T is equal to 1 second. Suppose in 1 second this values pass through this the observer. Now these are the waves which passing through, which crossing, which received by the observer in 1 second. Now when the initial position of the observer is this one, this is the initial position of the observer. Now at the end of 1 second, the observer moving away, this is the velocity of this observer moving away. The new position of the observer becomes this one. This is our new position of the observer. This is the new position. Now this is O0. So distance traveled by this observer in 1 second, suppose V0. So we know that velocity V0 is equal to distance traveled by the observer in 1 second t, and now our time becomes 1 second. Now therefore d is equal to V0. This is our formula. In 1 second the observer moves a distance of this one. Now that okay, so now the remaining our remaining waves which yes, now only in 1 second only that much of frequency, that much of the waves received by the observers, and these are the waves which reside in these regions are not received by this observer. It means that the frequency of the sound which appear to the observer is decreasing. So again I repeating this concept. Now at the beginning when both are at rest, at t is equal to 1 second, the number of waves received by the number of waves crossed by the observer is that one, that is f0. This is the original. Now when the observer moves from O to O dash, the number of waves which are residing in these regions will not be received by the observer. Only these waves which are present in this position in these regions are received by crossed by the observers in t is equal to 1 second. So therefore earlier the number of waves which present from here to here received by the observer, now only these waves are received by the observer. It means that the number of waves received by the observer is decreasing. So how much the apparent frequency now in this region? First we have to calculate number of waves in this region. So we know that this is the distance which moves in 1 second by the observer. Now the FA will be our apparent frequency. FA will be apparent frequency. Apparent frequency, or I can say that waves received by the observer, received by the moving observer So original waves received in 1 second is this one, and these are the waves which is present in the region will not be received by the observer. These waves will be v naught this distance divided by the wavelength of this wave. Now putting the value of, you know that original velocity of the sound in air is equal to original wavelength into original frequency. From here, if I place the value of original frequency, which comes out f upon f naught, if I place these values here, I will get the value of apparent frequency, which is f naught minus v naught divided by this much, f upon v upon f naught. F naught goes in the numerator. Now this goes in numerator. After simplification, f naught minus v naught into f naught divided by v. Now f naught is taken common from here. So if I common f naught from here, f naught, and this becomes 1 minus observer velocity upon sound velocity in air after taking the LCM. So after taking the LCM, so this becomes v go this side. Now v minus v naught divided by v. So now we know that the factor of f naught is less than 1 because the numerator is less than the denominator v and numerator v minus v naught. So therefore our apparent frequency is less than that of the original frequency. So in this way when the observer is moving from here to here in t is equal to 1 second, the number of waves received, number of waves crossed through the observer will be this value. Now let us practice one problems on this concept. Now let us discuss our concept in this problem. So an observer moves away from a stationary source of sound with a velocity of 1/5. This is our observer, it moving away. It is given that velocity of the observer is equal to 1/5 of the velocity of the sound in air. It means it is v upon 5. And velocity of sound is v is equal to 320 meter per second. Now it comes out 320 divided by 5, its value becomes 64 meter per second. So this is the observer velocity which is moving away, this one. So obviously the apparent frequency will be less than that of the original frequency. Now using the formula, apparent frequency is equal to v minus v naught divided by v into original frequency. Now simplifying this one, if I place the value of 320 minus observer velocity, which is 64, divided by 320 into f naught. 320 minus 64. Let us suppose stationary source has frequency f naught is equal to 500 hertz. So if I place this 500 is here, 320 minus 64 becomes 10 minus 4 is 6, and this is 11, 5 and 256 divided by 320 into 500. So this much of frequency is heard by the observer. After simplification, it comes out divide by 4. 4 6 24, and 4 into 4 64, 8 into 8 64. It comes out 8 into 50, it comes 450. No, it comes out 400 hertz. You see here, the apparent frequency is 400 and the real frequency of the sound is equal to 500 hertz. Our frequency decreased from 500 to 400. Now second part, find the percentage decrease in the apparent frequency. The percentage decrease will be, so we have the formula percentage decrease f minus original frequency my apparent frequency divided by apparent frequency multiplied by 100. This is our formula. Original frequency, because our frequency, the apparent frequency decreased from the original one. Original frequency minus apparent frequency divided by the apparent frequency multiplied by 100. This comes out f naught minus f. F naught has the value, original frequency is 500. Original frequency I have 500. 500 minus apparent frequency is 400. 400 divided by the original frequency, which is 500. So if you multiply by this one, now by simplification, 500 minus 400 becomes 100. 100 into 100 divided by 100. 1 divided by 500, and these two zero cancel out. Now if you divide this one, 100 upon 5, it comes out 20%. So our frequency is decreased in terms of the value, in terms of the percentage. The apparent frequency will be less than that of the original frequency.